Today we're looking at problems you'll see in AP Calculus, the first chapter on limits, indeterminate form, and we're going to look at derivative using the definition of the derivative, which is using the limits. So let's start with, I'm going to write, here's the problems that you'll see. And indeterminate form means if you place the number, replace it in x, substitute in x, what you'll have is 0 over 0. And that would mean that it's indeterminate. So how do you get that limit? So let's look at number 1. The limit as x approaches 49 of the function square root of x minus 7 over x minus 49. So what you want to do is you want to take the conjugate of the top and bottom, the numerator and the denominator. So I'm going to do that. I'm going to take the conjugate. Okay. And for notation purposes, follow through on the limit and everything. So top and bottom, this is a difference of squares, x minus 49. At the bottom here, x minus 49 times square root of x plus 7. Close parentheses. Okay. Now what I want to do is I'm going to factor out this, because x minus 49 and x minus 49, it's factored form. Okay. And what we have here is square root of 1 over square root of x plus 7. It's no longer indeterminate when you substitute in, so we can go ahead and substitute in your answers here. So I'm going to place it in square root of 49 plus 7 at the bottom, and it'll give you 1 over 7 plus 7, and your limit is 1 over 14 for the first one. And what you do is you apply the conjugate to the top and bottom. Likewise, the second one also, the limit as x approaches 100. Okay, so you go 10 minus square root of x at the top and x minus 100 at the bottom. What we're going to do is multiply the top and bottom by the conjugate, so 10 plus square root of x. So you multiply the numerator denominator by its conjugate. Okay. Follow through with the notation, x approaches 100 and difference of squares, 100 minus x for the top. This is x minus 100 and 10 plus square root of x here. Okay. So all I did is multiply top and bottom by its conjugate. Then what you do is follow through again, same thing, limit as x approaches 100. Now what I'm going to do here is I'm going to factor out the negative 1. So negative 1, x minus 100. The fraction bar here, x minus 100 times the quantity 10 plus square root of x. Okay. Notice that x minus 100 is a factor. It cancels. Then what you do is x, okay, as x approaches 100, the numerator will be negative 1, and the bottom will be 10 plus square root of x. We got the function in its simplest form. All we do next is substitute. Negative 1, 10 plus square root of 100. We simplify even further. What is square root of 100? 10. Negative 1, 10 plus 10. And I'm going to put the equal sign here to save space. Negative 1 over. So your answer for this one is negative 1 over 20. Okay. Now here's number 3. Number 3 is a page out of Algebra 2. Okay, so what is the limit as x approaches 2 of the function x cubed minus 8 x minus 2? Okay. So what you're going to do is you're going to change this. It says difference of cubes. So if you remember from Algebra 2, difference of cubes, quantity a minus b times the quantity a squared plus ab plus b squared. Okay. So that's what we're going to do here. We're going to factor in its factored form. Limit as x approaches 2. Okay. We identify x as a, b is 2. So what we have is x minus 2. Okay. And this one we have a is x squared plus 2x. Okay, all I did is multiply ab plus negative 2 squared is 4. All over x minus 2. Notice that cancels right there, which just gives you that one. As that's a polynomial. Direct substitution times 2 plus 4. 4 plus 4 plus 4 equals 2. And if I don't mess it up here, 4 plus 4 plus 4 equals to 12. Okay. It gives you the answer 12 right there. Just substitute everything in. Here's the first 3 here. Now I'm going to go back and move this down here a bit. Let's look at the derivative of the function f of x equals 3x squared minus 5x plus 1. We're going to use the definition of the derivative. Okay, so I'm going to move this paper up here. Go further up, further up. Okay, so just where you can see. So this next one, f of x, so I'll put 4 here. F of x equals 3x squared minus 5x plus 1. And I'm going to use the definition of the derivative. The limit as should be h. H approaches infinity of f of x plus h minus f of x over h. Okay? So I'm going to use that limit to find the derivative for f of x right there. So I'm going to go this one here. Number 4. F of x equals 3x squared minus minus 5x, plus 1. And I'm going to use the definition of the derivative to get the derivative. Of course, the derivative in next chapter will be much easier. For today, we're just going to use definition of the derivative. Limit as h tends to 0, approaches 0, of the function 3 times x plus h squared minus 5 times x plus h plus 1 minus, and I'm going to put the function here, 3x minus 5x plus 1 all over h. Now we're going to simplify. Rule of thumb, don't ever change. Always bring down the limits. Get a good habit of doing that. 3x squared plus 2xh plus h squared minus 5x minus 5h plus 1 minus 3x squared plus 5x minus 1 all over h. Do it again. Simplify till you get to the lowest possible. 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 1 minus 3x squared plus 5x minus 1 all over h. And what we do is we're going to simplify and combine like terms. That's gone. We got to get rid of this one, 5x and negative 5x. Of course, the ones are gone. And what you are left with is this one right here. Limit as h approaches 0, 6xh over h plus 3h squared over h minus 5h over h. Okay? So now, one more step. H approaches 0, 6x plus 3h minus 5. Once you get them into its reduced polynomial here, substitute, put it in there, 0, and what you end up with is 6x minus 5. So the derivative of f of x equals 3x squared minus 5x plus 1, using the definition of the derivative, is 6x minus 5.